Today on The Boiling Point, we'll be talking about the flame safeguard and how it actually works. I'm Richie Ware, and of course you know Steve and Taylor. We've got our burner management system with the Autoflame on this particular boiler. Maybe just walk through how the flame safeguard works when somebody walks in and says, hey, we're going to start this boiler. What does it actually do?
Yeah, when you flip the switch on, it's going to look at a bunch of different things because the burner management system, flame safeguard, it's got a bunch of different responsibilities. Main one is safety. And then to make sure that, before you ever start, it's going to make sure the gas valves are closed. You got gas valve proving switches on there, so it's going to make sure they're closed. It's going to prove they're closed. It's going to prove that there's not a flame in there already. Mm-hmm. And then when it gets ready to start, it's going to check and say, okay, I don't have a spark. I can start through pre-purge. As it starts through pre-purge, it's going to make sure that the blower motor starter is pulled in. Another interlock on a blower motor starter to make sure it's pulled in so that it doesn't start the blower, think the blower is running, and then go ahead and start ignition with no air flowing. So okay. Those are just all the different proving things that it goes through. And then the same thing when it lights goes through the ignition trial, it will energize the ignition transformer, open the pilot valves, and then it will look and make sure it's got a flame before it does anything else. It's going to prove the ignition period, the pilot proven period before it opens the main gas valves, because if it doesn't have a good pilot in there, you don't want to open the main gas valves, put gas in there and no way to light it off, because at some point it's going to. So you got to make sure that doesn't happen. So those are just some of the things on the startup.
This does not detect gas.
No.
Inside, though,
no.
Correct?
It does not detect gas. All we're looking for is, one, when we get ready to start and we start going through the proving cycle, the pilot proving cycle, do we have a spark? Do we have a pilot? Is the pilot strong enough to light the main flame? And that's through the scanner, which is reading the signal back through the BMS system to make sure that those are proper for lighting the boiler. And there's guidelines for what those signals need to be, whether it's volts DC or whatever the volts are. There's guidelines for that. So this thing is looking at it, and if the volts DC are 0 to 5 and it's only got 2.5, it's going to fail, and sound an alarm. Hey, we didn't have a good enough signal to light the main flame, so we're not going to let you light the main flame. We're going to open them gas valves up until we know the pilot is stable. And then when it's, some of the other things in the running interlock, when the unit's running and it's, you're up to high fire or whatever you're at, and it's looking at gas valves, make sure the gas valves are open. It's looking at the blower interlock switch. It's looking at a combustion air switch to make sure, okay, yeah, I've pulled my blower in, but my blower wheel fell off the motor, so even though my starter's pulled in, I don't have any air. We got an air pressure switch to make sure, yes, the starter's pulled in, the blower's running, but I also have air pressure on the combustion side to make sure I'm pushing air through there. Those are all the things. If any of that fails, the starter fails, we lose air, it shuts the boiler down, lights and sounds an alarm to make sure everybody knows what's going on.
And literally waiting for a person in that situation to come back and to
there's
check
your
things.
Manual reset that we talked about last week.
Right.
It's all manual reset to, hey, somebody has to look at it before it'll start back up, go back online again.
And then it'll go through all the same, sequence.
Same thing. It'll go when it shuts down. It doesn't just shut down. If the blower is still able to run, then it will go through a post-purge, which is a timing thing. It'll drive the thing to high fire with no fire in there. It'll drive the firing rate all the way up, count the number of seconds that's programmed in the BMS to make sure we have enough airflow changes through the chamber for any gases that are in there. It pushes them out the exhaust and gets rid of them. Then it will shut down, sound the alarm, and then when somebody recognizes that, resets it, things start back up, it'll do the same thing. It goes through pre-purge, shoves all those gases out, make sure there's not any gases lingering in there, and when it's doing that, then it's proving all the circuits are made. gas valves are closed, air proving switch is proper, we don't have a flame in there, so it's checking for flame to make sure there's nothing in there, goes through all those cycles to make sure. And, I mean, its primary job is safety and going through the process. So the flame safeguard is just that, to make sure the flame is in there and make sure it's a safe operating condition, and that's all the other things just to add in there to make it a proper system.
Is it any different when it's a cold start where it's totally down versus hot and then restarting?
That all depends on how the controls are set up. We like to set up a low fire hold control to keep the boiler on a cold boiler from just going straight to high fire. Because if you don't have that set up, the boiler and the burner management system is saying, hey, my pressure is at 10, I need to be at 120, it's going to run as hard as it can run to get there. We like to set a low pressure or low fire hold control so that the boiler has to get up to a certain pressure before to let it run. That way we don't take a cold boiler, throw fire into it, it's too much shock. The system, it'll handle it a couple times most of the time, but if you do it over and over and over, it's going to take the refractory out, it's going to take the rear tube sheet out. They're not designed for that. Fire tubes are not designed for that. They won't take it. You'll end up destroying the boiler.
So now, again, this burner management system, it's got the flame safeguard included, right? Now, in the older days, you had the Honeywell, and you still have Honeywell. You still got the Fireye flame safeguard.
Yeah.
Kind of the difference in that.
One of the major differences is with the burner management system, we're running the combustion modulation system. We're monitoring everything in that burner management system. With the flame safeguard, its primary job is looking at the flame and checking the approval. This is more sophisticated.
Right.
It just has more controls, more things that's running through there than what the original flame safeguard did.
Right.
But it has that built into it.
It's got it in it.
But it just has more features to it.
Okay.
We're going to look at something we don't always look at, which is jumpers on our flame safeguard controls. Usually hidden behind the display module, it might be something that we've never even really looked at. But if we get a new flame safeguard control, they're an important part of making sure that our system functions the way that it's designed. What these jumpers do is allow us to change or modify the behavior of the control according to the installation. And that may be important based on the flame detector amplifier timings, or whether or not we've got a blower motor contactor, or we're running a fan directly. So I'm just going to touch on a couple different jumpers, or 3 or 4, and talk about what they do. On this unit, the 7895 is really designed for a burner with a blower, but it's usually used on a fairly smaller scale application. That said, we may have a blower motor that's powered directly from the 7800. On larger units, we don't have that. We usually use a 3-phase contactor to run the fan. But because we're running the fan directly from the flame safeguard in some applications, we don't have a blower motor start interlock and other things that we will be checking. So the jumper 3 on this, if we remove it when it's new, before it's burnt in, will actually verify the operation of our air switch. What it will do is verify that it closes when there's a command for the fan, but it will also check that it's open when the fan output is off. So that's a neat additional safety enhancing feature. Jumper 2 on this gives us a recycle or lockout operation. On boilers, if we lose flame, generally we're going to lock out. But on some air handlers and some other applications, relighting attempts are permissible, assuming that we've got the correct amplifier timing picked. So I've installed these before and got faults because I had a normal what I call normal 3-second amplifier in there, but the relight jumper was intact. So I was required to have a faster response time, and I didn't. So you just want to take a good quick look at the jumpers in a control and make sure, especially when you're replacing one, that you set or remove the jumpers according to how the original was. If you've had a unit in place and you've got beyond a certain number of run hours, changing those jumper configurations are going to brick the control. So It's something we basically do on a new unit installation to match the old one.
Well, welcome to the Boiling Point. I am Richie Ware, and this is Brian Grindstaff. Now, Brian obviously runs the Boiler Warehouse division, and he had some ideas here. Now, Brian, I know the blue box is popular and Autoflame flame safeguard and stuff like that, but we got a red box here in Fireye.
So what we got here are actually 3 different versions of a Fireye.
Okay.
You know, we talked about the blue boxes. The colors of these flame safeguards are very iconic.
Right.
Honeywell with their blue,
Sure.
Fireye with their red. Autoflame's got their little white, light blue kind of tint to
Sure,
them.
sure.
But Fireye is definitely one of the most prominent flame safeguards out there for process burners, and boiler burners,
Okay.
ovens. You know, you see these red boxes all over the place.
Yeah.
And what I've got here are basically 3 different versions. Fireye actually makes a lot of different steps of here's just your basic operation to, you know, I want something that's going to monitor the whole boiler room.
Okay. Okay. And that's how these different ones actually have, I guess, different parameters that it actually does, right? As far as
Yes.
based on if you need a little bit more, you know, or you're going to need something like that to really kind of just give you some, maybe some failures or whatever that happens. This one would give that.
Yeah, so the logic for the flame safeguards are pretty much the same. From you know, a lower BTU burner, as you go climbing BTU, like basically there's a division line at 12.5 million.
Okay.
12.5 million and below tends to fall under CSD1. 12.5 million and above tends to go to NFPA 85 or NFPA 86 for ovens and furnaces.
Okay.
So depending on where you fall in that, I mean, the safeties are pretty much the same for burners, but you may want some added features, and then your customers may want some added enunciation to be able to know when this thing locks out, you know, why did it lock out? Where was my issue?
Right.
So you'll start to see that. And then also, you know, they make a parallel positioning to be able to do combustion control as well as just the burner management flame safeguard functions.
Right. Right.
So you get your linkage list with that also. And then also plant masters kind of tie in.
Right.
What I got pictured here are really the everyday boxes. I don't
Sure.
have the PLC or anything here to show, but you know, you basically got a Y series control, which is a good boiler burner control. You got an E110 that you see all over the places with process burners and everything else. And then you've got an MEC control, which is another one of those controls that's iconic that you just see all over the place.
Right. Cool.
And each one of those boxes there, you kind of build out and trim out based on the burner. So what's pictured here is a chassis, but there's actually a sub base and a programmer and a amplifier and other pieces that plug into these things that actually give you the customization for each burner.
Oh, nice.
So depending on which amplifier you pick, will be the scanner that you pick with it.
Okay. So this is a scanner.
Yep. So what you got in your hand there, that is a self-check scanner. This right here, that's a UV scanner. This is also a UV scanner.
Okay.
The self-check version actually has a check that it does every so often to make sure and verify that it's operating correctly.
Okay.
These other ones are more of an analog process. It's either on or it's off.
Right.
This one actually does a safety check. And depending on how you're operating your burner and your run time and how often you cycle that burner off and on, you may be required to have a self-check.
Sure. Awesome. Awesome.
Yep.
Anything else you got? You good?
No, just to
we
say
covered all?
that, you know, we try to help with all types of flame safeguards. So
Right.
we, you know, we're ingrained to be able to help on the blue boxes, the red boxes. You know, I don't have all the parts listed out here, but our shelves are full of all the customizable parts
Sure.
to be able to quick ship for customers.
Right. Right. Yeah. Whether it's like you said, Honeywell or Fireye or Autoflame, you know, boiler warehouse tends to be able to take care of everything in the boiler room. Welcome to The Boiling Point. I'm Richie Ware, and this is Gerald Blaine. Now, the red and the blue box, that's something that's really standard, of course, out into the industry. That's the flame safeguard. Gerald, real quick, maybe just tell us about what in the world these flame safeguards actually do. We got the Fireye, you've got the Honeywell.
Well, these are the BMS system, the burner management. This is where all the safeties get checked out. So these are critical on any system. Even when you have a full-blown, say, parallel positioning system, you're going to have something of this nature, whether it's the Honeywell, a Fireye, or built into an Autoflame, as an example.
Okay, and you know, some people maybe just hearing that what the flame safeguard or the BMS, what is it actually doing? Because this is really the brains of the.
Yeah, it's making sure that things get purged properly, that there's flame detection to make sure no one pumping gas into the boiler and there's no flame there present, so that we can avoid explosions and things of that nature.
Okay. Okay, so, you know, as we're continuing to go into more and more technology, there's actually a product that has really kind of come out. Autoflame's not new, but maybe talk a little bit about the Autoflame Flame Safeguard.
Yeah, what we've done is the Mini 8 design has a feature now where it can just be a flame safeguard.
Okay.
Sometimes other products have been more difficult to get. Autoflame had it available. The BMS was always in there. So they just opted out all the other parameters and said you can use it purely as a flame safeguard.
So literally, they've got you know, a Honeywell on there. This can come in and replace it.
Yep.
Okay.
And or say a Fireye or anything that was serving as the BMS, you can use this just for that feature.
And what are the advantages, I guess, when you do that? Because obviously it's going to do exactly what this does.
Right.
But then why would we want to even do that?
Well, the advantage that you could have is, say, if you had, being that this is on the Mini 8 platform, you could, at some point on, say, a 300 horse and below, the smaller type systems, you could convert this over by getting an unlock code and then getting servos and the additional hardware, and you could operate it as a parallel positioning system.
So you have a linkage system, basically, and then all of a sudden you're going to servo motors.
Right.
And having those servo motors, tighter control, more
Right.
efficiency.
Definitely some added fuel savings and so forth.
Okay. Now you mentioned something at 300 horsepower. Obviously, there's bigger boilers out there. So what is it that they do there?
Yeah, and if you had a bigger boiler and you were going from this, you would typically go to our full-blown MK8 system because it has additional features like enunciation, water level control, automatic TDS, a variety of features that you're not going to get at this level.
Okay.
But at 300 and below, you might not be looking to have those features.
Okay, awesome. All right, well, so you got some technology that obviously is out there with the Honeywell, the Fireyes, you know, that are out there, but Autoflame has now got their control that then could potentially get you some more control out there. But stick around. Right now, you're actually going to hear from Autoflame, and they're actually going to go through all of the features about the Autoflame Flame Safeguard.
The Autoflame Flame Safeguard is designed to be a swap-in replacement for your typical flame safeguard that you're used to seeing on site, interfacing with your existing mod motor and thermostat controller. The device is going to output your pre-purge, light off and release to modulate commands, monitor the flame and control your burner outputs just like a typical flame safeguard. However, as is the Autoflame way, we've also encompassed many additional features into the Autoflame Flame Safeguard, such as password protection, customizable safety times, downloadable data, valve proving, and many more. Now, the Autoflame Flame Safeguard carries the same hardware and approvals associated with the Mini Mark 8mm. So when your customer is ready, they simply need to software unlock the Flame Safeguard to enable the full range of features that you get with the Mini Mark 8mm. Here I am using the Autoflame Flame Safeguard to control a Modutrol motor. We do this by utilising our channel 1 switch neutral outputs wired through 2 relays, which are detailed next to me here. Now, these 2 relays ensure that the correct commands are driven from the Flame Safeguard to the Modutrol, and once the device is happy, we will release the Modutrol to modulation. When this happens, we relinquish control from the flame safeguard, switching over to a 0 to 135 ohm signal from the pressure trough. Now, the relay module that I've got next to me here from Autoflame is optional, and you may wish to use existing relays or your own relays entirely. When you purchase your Autoflame flame safeguard, there is a new option 109 which will automatically be enabled. This is your flame safeguard mode. You can see here, if I come back to your main commission mode menu, commission, gas pressure commission, air pressure commission, and your commission data are all disabled. That's because there is nothing to commission within the system. However, if I go to my options and BC down here, these are all your burner control options, meaning all of your customizable safety times for your gas and oil are all present within the system. Here I am in the run mode of the Autoflame flame safeguard. Now, this screen will be pretty familiar to you. However, this is now the only screen that the customer is going to be looking at. However, we do have a few options down here, so we can access our options and parameters, however, only in read-only mode. We can view our run times, defining when the burner switches on and when it shuts down. We can also go to our system log, which is sort of a combination between your fault log and any configuration changes within the system. And then, of course, your familiar fault log, where we can look at your lockout history, errors, alarms, and your warnings. And we can also navigate to history up at the top here, where in this case, we're using a flame rod, so we're monitoring your ionization signal. However, the same UV and IR configurations that you're used to seeing on the Mini Mark 8 are also available on the flame safeguard. Any faults within the system, your runtime schedule, and your Terminal 53 running interlock circuit will all shut down the burner, and these will be logged in your fault log and your system log. Now, Terminals 70 and 71 are switched neutral outputs from the flame safeguard and provide the high initiate, low initiate, and release to modulate commands via those two relays. Now, when Terminal 71 is low and Terminal 70 is high, the motor moves to purge. When Terminal 71 is low and Terminal 70 is low, the motor moves to light off. When Terminal 71 is high, however, the motor then is released to modulate via your external pressure controller. Now, I've got here my option 154, which in this case, I need to enable my start position interlock. In option 155, I then need to enable my purge interlock. So both my purge position interlock and start position interlock must be enabled. Now, I can optionally use terminal 82 for valve proving, where I'm going to use a low gas pressure switch input and enable it via option 156. Here I am in the run mode of the Autoflame flame safeguard. So if I enable my burner, as in I'm putting a voltage input into terminal 53, my running interlock circuit, and assuming there are no active faults or nothing preventing the burner from starting, it's going to go through its startup phases. So we've just completed our fail-safe relay checks. We are checking the air switch at this point, and now we're running to purge. So we've output a signal from the flame safeguard to our mod motor via those two relays, and we are moving the linkage arm to its purge position. Now I have a 20-second pre-purge time set on this flame safeguard. The default is 40, it's purely 20 seconds just for this demonstration. So you can see here the same phase description that you're used to seeing is available on the flame safeguard. We can see exactly how long we are purging for. So there are two switches, end switches within the mod motor, and when they make, they will put an input into the corresponding terminal of the flame safeguard. So we have proved that we met our purge position. We're now running to our light off position, meaning the motor is now driving to its light off point. Now once this switch makes, we put another input into the flame safeguard. And this is how we ensure that each phase can move on to the next. So there we go, the end switch was made. We're now moving to ignition and pilot. After pilot proving, we then energize our main fuel valves, so all of your standard burner outputs. And once our main flame proving time has elapsed, we then release the motor to modulate. Now, as I said, we then relinquish control from the flame safeguard to our pressure trough. Now, I actually have a potentiometer wired up to my motor, and this will simulate a 0 to 135 ohm signal from the pressure trough. So we can see we've now hit a fixed point of modulation in just a moment. Now, if I then start rotating my potentiometer, you'll see this linkage arm start to move. So if I rotate it one way, which is just a proportional 0 to 135 ohm signal, you can see my linkage arm moving this way. If I rotate the other way, we're now going to start moving clockwise. Now, when your customer is ready to upgrade their Autoflame flame safeguard, we will issue you with an unlock code. Exactly the same as the Mark 8mm, that unlock code can be uploaded once in commission mode, either via the download manager, or you can actually type it in via the on-screen keyboard. I do have a few slides here that just go through that process. Now, once your Autoflame flame safeguard has been unlocked, you need to navigate to option 109, which is your flame safeguard mode, and disable that. Now, once you do that, you're enabling the full functionality of the Mini Mark 8mm. Now, we do have 3 new part numbers associated with the Autoflame flame safeguard, which I've got listed here. If you've got any questions about anything to do with the Autoflame flame safeguard, please do get in touch with me using our normal channels that you contact me on.